Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover about gamma function and properties of gamma function and problems on this. So first let us see what is the basic definition of gamma function. So this is the notation of gamma function, gamma of n, and it is defined as integral 0 to infinity e power minus x power n minus 1 dx. We have different properties of gamma function. First property, gamma of 1 equal to 1. So if we want to prove this result, substitute n equal to 1 in this. So if we want to prove gamma of 1 is equal to integral 0 to infinity e power minus x into x power n minus 1, substitute n equal to 1, so we get x power 1 minus 1 dx. So this is integral 0 to infinity e power minus x dx. So integration of e power minus x is e power minus x by minus 1, limits are 0 to infinity. So upper limit e power minus infinity is 0, minus lower limit is 1, so this is 1. Therefore gamma of 1 equal to 1. In this way we can prove any result using basic definition of gamma function. Right. Next, relation between beta and gamma functions. Last lecture we have seen what is beta function, beta of m comma n, and gamma function, gamma of n. The relation between these two is beta of m comma n equal to gamma n m into gamma n by gamma of m plus n. And we have one more property, gamma n into gamma of 1 minus n equal to pi by sine n pi. And next result is gamma of 1 by 2 equal to root pi. These are the few important properties of gamma function. Next, if n is a positive fraction, say gamma of n can be written as n minus 1 into n minus 2 and so on into n minus r into gamma of n minus r. If n is a positive fraction, right? Say for example, if I want to find gamma of 7 by 2, 7 by 2 is a positive fraction, isn't it? So this can be written as 7 by 2 minus 1 into 7 by 2 minus 2. You like that, you subtract 1, 2, 3 and so on. Where you get negative fraction, you stop it there. So 7 by 2 minus 2 is positive into 7 by 2 minus 3, this is also positive. If you write 7 by 2 minus 4, you get 7 minus 8, that is negative. So stop it here. Then 7 by 2 minus 3. So 7 by 2 minus 1 is 5 by 2 into 3 by 2 to 1 by 2 into gamma 1 by 2. This is gamma 7 by 2. So this is 5 by 2 into 3 by 2 into 1 by 2. Gamma 1 by 2 value is square root of pi. So this is the value of gamma 7 by 2. Let us evaluate the small integral using gamma function. Evaluate integral 0 to 1 x power 5 1 minus x whole power 3 dx. So first of all, we can see the limits are 0 to 1. So we can convert this integral to the beta function. Then using gamma function, let us simplify or evaluate this. So this integral can be written as x power, this 5 can be written as 6 minus 1 into 1 minus x whole power, this 3 can be written as 4 minus 1 into dx, right? So this is equal to beta of 6 comma 4, because we know that definition of beta function is beta of m comma n is integral 0 to 1 x power m minus 1 1 minus x whole power n minus 1 dx. So we compare these two, find the values of m comma n and substitute here. we get beta of m comma n, that is beta of 6 comma 4. If they ask to convert the integral in the form of beta function, so let us stop here. But he is not asking to express in the form of beta function, instead to evaluate the integral. So just now we have seen beta of m comma n is same as gamma m into gamma n divided by gamma m plus n, isn't it? So this is gamma 6 into gamma 4 by gamma 10 using this result. But gamma 6 can be written as 5 factorial, gamma 4 can be written as 3 factorial, by gamma 10 can be written as 9 factorial. So 5 factorial into 3 factorial is 6, by 9 into 8 into 7 into 6 into 5 factorial. So 5 factorial cancel, this is 6 cancel, 1 by 9 into 8 into 7, this is the answer for this, right? Let us evaluate one more problem. Evaluate integral 0 to infinity x power 6 e power minus 2x dx. If you see the limits 0 to infinity is there, we cannot apply beta function. First, let us try to convert this in the form of gamma function. We know that gamma of n equal to integral 0 to infinity e power minus x power n minus 1 dx. If you compare these two integrals, x power n minus 1, we have x power 6, so 6 can be written as 7 minus 1, nothing to worry. But e power minus x should be there, we have e power minus 2x. So let us take this 2x is equal to y, or x is equal to y by 2, isn't it? Suppose if we have 5x here, you can take 5x is equal to some y or k, whatever it is. Now x equal to y by 2, differentiate it both sides, dx is equal to dy by 2. Limits will be interchanged, lower limit x equal to 0, so substitute x equal to 0 here, y is also 0. Upper limit x tends to infinity, so y is also tends to infinity, so limits are not getting changed. So this can be written as integral 0 to infinity x power 6, x means y upon 2 whole power 6 into e power minus 2x, e power minus 2x means y, so e power minus y dy. So this can be written as integral 0 to infinity e power minus y into y power 6 by 2 power 6 dy. So this 1 by 2 power 6, write it outside, integral 0 to infinity e power minus y into y power, this 6 can be written as 7 minus 1. So 1 by 2 power 6 means 2 to 4 to the 8 to 16 to 32 64. This integral can be written as e power minus y into, see the gamma function definition, y power n minus 1, in place of n we have 7, so this can be written as gamma 7, but gamma 7 is 6 factorial divided by 64, so this can be written as 6 into 5 into 4 into 3 into 2 into 1 divided by 64. So if you simplify this, we get 4 8s, so 2 3s, 2 4s, 15, this is 5 3s 15, 15 3s 45 by 4, right? Let us evaluate one more integral. Evaluate 0 to 1 sin power 5 theta cos power 7 by 2 theta d theta. In already we have seen, we know that in beta function there is one property 1 by 2 into beta of m comma n equal to integral, evaluate integral 0 to 1 sin power 5 theta cos power 7 by 2 theta d theta. This is not 0 to 1, okay, 0 to pi by 2. So we know that 1 by 2 into beta of m comma n can be written as integral 0 to pi by 2 sin power 2m minus 1 theta into cos power 2n minus 1 theta d theta. We can compare these two integrals. So sin power 2m minus 1 is there, here sin power 5 is there. So 2m minus 1 equal to 5. So that is 2m is equal to 6. So we get m equal to 3. Right. And compare power of cos. We have 2n minus 1 is equal to 7 by 2. So 2n is equal to 7 by 2 plus 1, that is 9 by 2. So n equal to 9 by 4. So anything to convert into beta function, we want m comma n values. So I got m comma n. So this integral can be written as 1 by 2 into beta of 3 comma 9 by 4. To express this result in the form of beta function, we can write up to this step. Suppose if they ask to convert the integral in the form of gamma function, then this beta function can be transformed into gamma function using the relation between beta and gamma function. So this is m and this is n. This can be written as gamma m into gamma n by gamma m plus n, that is 3 plus 9 by 4. So this can be written as 1 by 2 into gamma 3 is 2 factorial, gamma 9 by 4 by gamma 4 3 is 12 plus 9, 21 by 4. 2 factorial cancel. So using the result gamma n, if n is a positive fraction, this can be written as n minus 1 into n minus 2 and so on, n minus r into gamma n minus r. So this can be expressed as gamma 9 by 4 by gamma 21 by 4. So gamma 9 by 4 can be written as 9 by 4 minus 1 into 9 by 4 minus 2. Suppose if I write 9 by 4 minus 3, it will be getting negative. So stop it here, into gamma 9 by 4 minus 2 divided by gamma 21 by 4 can be written as 21 by 4 minus 1, 21 by 4 minus 2, 21 by 4 minus 3, 21 by 4 minus 4. You go on subtracting 1 from the number until you get negative fraction. So 21 by 4 minus 5 into gamma 21 by 4 minus 5. So if you write 21 by 4 minus 6, so you get negative. So this can be written as 5 by 4 to 9 by 4 minus 2 is 1 by 4 into gamma 1 by 4 divided by 17 by 4 into 21 minus 8, 13 by 4, 21 minus 12, 9 by 4 into 5 by 4 into 1 by 4 into gamma 1 by 4. Gamma 1 by 4, gamma 1 by 4 cancel. So this is equal to 4 in 4 by 17 into 4 by 13 into 4 by 9. We can simplify this, right? Let us solve this problem. show that integral 0 to 1 x power 4 into log 1 by x whole cube dx equal to 6 by 625. So here let us take log 1 by x is equal to some t or y or anything. So 1 by x is equal to, if I remove this logarithm from left side, I can write this as e power t. I want x value, so this can be written as e power minus t, isn't it? So if you differentiate both sides, dx is equal to minus e power minus t dt. So lower limit of x is 0. If x is 0, log 0 is infinity, log infinity is infinity, so t tends to infinity. And upper limit, substitute x equal to 1, substitute x equal to 1 here, so you get 1, log 1 is 0, so we get t value 0. So this integral can be written as log 1 by x whole cube dx. So at x equal to 0, t tends to infinity, and at x equal to 1, t equal to 0. And x power 4, x means e power minus t whole power 4 into log 1 by x means t whole power 3. dx means minus e power minus t into dt. So if I remove this minus sign, the limits will be interchanged, t equal to 0 to infinity. This e power minus t whole power 4 can be written as e power minus 4t into t cube e power minus t dt. So here e power minus 4t, e power minus t, from this step we get e power minus 5t into t power 3 dt. To express this result in gamma function, again this should be only t minus t, but we have 5t. So let us take this 5t is equal to some again u, or t is equal to, we have u by 5. So dt is equal to du by 5. So this integral can be written as t0 means you get u0. If t tends to infinity, we get u also tends to infinity. So u equal to 0 to infinity, e power minus 5t means u. So e power minus u into t power 3 means u by 5 whole power 3. dt means du by 5. So this can be written as integral 0 to infinity e power minus u to 5 power 3 u power 3 du into by 5, u power 3 by 5 power 3 e power minus u by 5 power 3, right? So this is 5 power 3 is 625, write it outside. 0 to infinity e power minus u into u power 4 minus 1 du. This 3 can be written as 4 minus 1. So this integral can be written as gamma of 4, but gamma 4 is 3 factorial by 625. 3 factorial is 6 by 625. This is what we have to prove, 6 by 625. Thank you.